Hi everyone, this is the second video session on summation of two polynomials. In the first video session, we talked about how to get two inputs from the two polynomials as inputs from the user and store them in dynamically created arrays. And also we talked about how to present polynomials on the console in a formatted way. In this video session, we are going to talk about the algorithm of summing of two polynomials given that they are stored in the arrays. And one of the basic assumptions that we are going to take here for the algorithm is that the terms of the polynomials are entered by the user in decreasing order of their power values. So let us take some examples, one example, and discuss the algorithm, and then we would go for implementing it. So here we have two polynomials arranged in decreasing order of their power values, and the sizes of the two polynomials is coincidentally 4, but we can take polynomials of any sizes. Our algorithm would be generic enough to handle polynomials of any sizes. So in the first video session, we said that the maximum number of terms in the resultant polynomial would be equals to the summation of the sizes of these two polynomials. So here the sizes of these two polynomials are 4. So the size of the resultant polynomial can be at the max 8, and the maximum value would be reached only when if there is no overlap between the power values of the terms of these two polynomials. But here in this example we have some overlap. Here we have x to the power 5 term, here also we have x to the power 5 term, also we have x squared term in both of this polynomials. So the size of the resultant polynomial would be lesser than 8. But in general, the maximum size of the resultant polynomial can be summation of the sizes of the two polynomials. So let us start with representing an array of size 8 in which we would store the result. So we would have an array of size 8, and now we would have three variables pointing to I, j and k, which store current index of these three arrays, and we would initialize these variables with 0. Now within a loop we would check some condition, and the conditions would be like this. We would check the power values of the terms at ith position and jth position, and if the power value of one of these two terms is greater than the other, then the term which has greater power value would be copied to the result array. So here if you see 4.7 x to the power 8, here power value is greater than x to the power 5, so this term would be copied to kth position of the result array. So 4.7 x to the power 8. Because of lack of space, I would be writing it like this, 4.7 then x to the power 8 here. Now after copying this term, the value j and k would be incremented. Whichever term has got copied, that particular index would be incremented by 1, and the results array's index would get incremented by 1. Now there can be another condition in which both of the powers are same. Powers of both of the terms are same, like what has happened now. The terms of ith and jth position has equal power. In this case, what we would do is we would sum up the coefficients of these terms. So here it is 3.2 and 3.9, and we would copy to the coefficient value of the kth term of the result array. So 3.2 plus 3.9 is 7.1, and the power value would be copied as it is. So here it is x to the power 5 and x to the power 5, so it would be copied as it is of any of these two terms, right? So in the structure variable we would have just 5, but for understanding purpose I am also writing the unknown variable over here, that is x. And now after copying this new term at kth position, we would increment all these three variables. So I would be incremented by 1, j would be incremented by 1, and also k would be incremented by 1. So here is a difference, that if one of the terms has a greater power value, then that would be copied, the greater power term would be copied to the kth position, and only the index variable that stored the greater term, that would be incremented by 1, and also the index variable of the result array would be incremented by 1. If the powers are equal, then we are going to sum up the coefficients and store it in the kth position of the result array, and we are going to copy the power value as it is, and in that case we are going to increment all the three variables by 1. So we would repeat the logic till one of the polynomials run out of terms. So keep on repeating this logic. So here if you see, it is 9x square, and the jth term here is 4.2x cube, and here this term has a greater power, so this would be copied, 4.2x cube would be copied, and j would be incremented by 1 and k would be incremented by 1. Again we would repeat the comparison. So here we have x square, here also we have x square, so we have equal powers. In this case we are going to sum up the coefficients. So 9 plus 7.0 is 16.0, and the power value would be copied as it is, and I, j and k would be incremented. All the three variables would get incremented. Now we have a special scenario in which one of the polynomials has run out of terms, that we have exhausted it. Now all the remaining terms of the other polynomial would be copied to the result array starting from kth position. So here the remaining terms are 5.2x and 10.3, so those would be copied to the result array, sorry, x 5.2x, I would be incremented and also k would be incremented. Again 10.3 would be copied, then k would be incremented and I would be incremented. Now the first polynomial has also got exhausted, so we would stop here and then we would print the result on the console. So if we sum these two polynomials, indeed this would be the result that we would get. Now let us go ahead and implement it. So this is the algorithm, and now we would go for implementation. So for implementing addition of two polynomials, we would have a separate, we would create a separate function, and we would name it as add polynomials. Add polynomials, and this is going to take few parameters. First of them would be pointed to the first polynomial, struct polyterm asterisk poly1, and the second parameter would take the size of the first polynomial. Then we are going to take the pointer to the second polynomial, sorry for the typos, polyterm asterisk, let us call this pointer as poly2, and then size of the second polynomial, and then we are going to take the pointer to the result array. So in the first video session we have already allocated an array for storing results, so that particular array's pointer would be passed over here. Let us call it as result poly. Fine. After defining these parameters, now let us write the code within the function. So here we would start with initializing the 3 index variables that we talked about in the algorithm, and we would initialize these 3 variables with zeros. Now we would have a loop within which we would check the power values of the terms of the 2 polynomials, and as we said, the loop would run till we have run out of till one of the polynomials has run out of terms. So for that, for checking whether any of the polynomials has got exhausted or not, we would have this condition till I is less than size 1 and j is less than size 2. That means if this condition is satisfied, that means we have still some terms remaining in both of the polynomials to be considered, right? I is less than size 1 and j is less than size 2. When any of these polynomials runs out of terms, then either I would becomes equals to size 1 or j would become equals to size 2, right? Now within this loop, we are going to compare the power values of the terms at ith and jth position. So we would write poly1 I dot power. If it is greater than jth term of second polynomial power, then we are going to copy the term at ith position of first polynomial to the kth position of the result polynomial, k and poly1 I, and then we are going to increment both k and I, else if the second polynomial's term has greater power value than first polynomial's ith term, then we are going to copy the term at ith position, jth position of second polynomial, and then we are going to increment both k and j. If both conditions are false, that means the two powers are equal. In that case, we are going to sum up the coefficients of the ith and jth term of these two polynomials and then store it in kth position of the result array. So kth position of the result array, here the coefficient would now be poly1 I dot coefficient plus poly2 j dot coefficient, and the power value can be any of the power values of any of the terms at I and jth position. So let us assign the poly1's power value of poly1's ith position. Well, in this case, all the three values, all the three indices would get incremented by 1. Well, after this loop, when we run out of terms of any of the polynomials, then we'd come out of the loop because any of this condition would become false, and then the terms in another polynomial, the remaining terms in another polynomial would be copied to the result array starting from kth position. So to check which because of which polynomial has run out of terms, that we come out of this, the control came out of this while loop, we would have a condition here. So if I has become equals to size 1, then first polynomial has run out of terms. In this case, all the remaining terms of the second polynomial would be copied to the result array. So till j is less than size 2, so all the remaining terms, for that we would need to have this condition, j less than size 2 would be copied to kth position, starting from kth position of the result array. Result poly k equals to poly 2 j, and we would increment k and j both. And if else if j is equals to size 2, then the second polynomial has run out of terms, then we are going to copy all the remaining terms of first polynomial to the result array. So let me copy it over here. If I is less than size 1, then we'd copy all the terms of first polynomial to the result array. So with this, I think we have completed this function, and before calling it from the main function, let me declare its prototype before the function. Well, I have declared the prototype. Now we would make a call to add polynomials from the main function, and then we would pass the parameters to it. The parameters would be pointed to the first polynomial, size of the first polynomial, pointed to the second polynomial, size of the second polynomial, and pointed to the result polynomial. Add polynomials, and then we are going to print the result polynomial. So after polynomials, add polynomials has done its job, result poly would be containing the resultant polynomial, and that we are going to print it on the console. So result poly, and as second parameter we need to pass the size of the result array, so which is equals to size 1 plus size 2. Let me compile it once. So it has compiled correctly. Few things that are needed to be changed in print polynomial is this condition. So in the first video session we talked about an assumption that the user would never enter a term with 0 coefficient, and whenever we would find a term with 0 coefficient, we would break out of the loop. We would not go ahead with printing the terms anymore, and we were considering coefficient 0 as to be the end marker of the polynomial, but we would get rid of this assumption because the resultant array might have a term with 0 coefficient if one of the terms of first polynomials has a coefficient which cancels out with coefficient of a term in the second polynomial, then definitely we can have a term with a 0 coefficient in the result array. So in that case we are going to skip that particular term with 0 coefficient, and we would continue printing the next terms. So instead of break over here, we would write a continue, so that we can continue printing the next term, and we would skip the term with 0 coefficient. So this change that we have made over here. Another little change that we need to make here is this appending of a plus after the terms. So here the result array might not have all the positions filled up. Like in this case, if you see, we have 8 positions in the result array, but we have only 6 terms in the result array. The remaining terms are all filled up with zeros, as we have used calloc, so remaining terms would be all filled up with zeros. Now if we give this particular result to the print polynomial function, it would append a plus after 10.3 and it would skip all the 0 terms. So 10.3 plus, that is how it would represent the polynomial on the console, and that would be incorrect to have a plus appended after 10.3, right? So these terms except the first term must have a plus before the terms. So here instead of appending, we are going to prepend plus if it is not the first term, right? So this is the change that we are going to make over here. We would bring this above the statement which is printing the term, and we would prepend a plus before the terms if it is not equals to the first term. If it is not first term, then we are going to prepend a plus, right? So these are the changes that we have made to print polynomial. Hope it would run fine now. And one more little thing is that we need to have a space here. So in previous run there was no space given here, so we would add a space over here. Well, now let us compile and run it and test it with this test case. So we have two polynomials of size 4. The first term is 3.2 x to the power 5. The second term is 9 x to the power 2. The third term is 5.2 x to the power 1, and the fourth term is 10.3 x to the power 0. That is the constant term. Now second polynomial's first term is 4.7 x to the power 8, 3.9 x to the power 5, 4.2 x to the power 3, 7.0 x to the power 2. Well, let us now check whether it has correctly printed the result or not. So I've forgotten to prompt that this is the result. So if you see the second polynomial is coming up to here, 7.0 x square, and the result is printed from here starting from this 4.7. So 4.7 x to the power 8, 7.1 x to the power 5, 4.2 x to the power 3, 16.0 x to the power 2, 5.2 x to the power 1, and plus 10.3 x to the power 0. So the result is coming out to be correct. So our program has worked perfectly. Only thing that we missed is to add a new line character, or we can just prompt the user that the result of summation is like that. The result of summation, and after that we can print the polynomial. So with that we have completed this program, and I hope you have understood the logic. So after all this, what we have learned here is the algorithm to sum two polynomials, and also we have learned how to dynamically allocate structure arrays. So these are the key takeaways from this video sessions, 2 video sessions. Hope you have enjoyed and learned a lot from these video sessions. So keep watching my videos and keep learning better and better coding. Thank you. Thanks for watching. Bye.